Okay, and we are recording. This is lecture 34. Lecture 34. This is going to be on matrix multiplication. Okay, so while I have everybody in here, I'm sitting here in my classroom. I am hanging out with Coach Colbert. He is right beside me here. And we just wanted to remind everybody that all work for this semester is going to be due tomorrow night. So I wanted to make sure everybody knows that all the work that you need to send to your teachers, whether they're me, whether it's somebody else, all that work is going to be due tomorrow night. Okay. Because the last day that we can put grades in is uh, tomorrow. Maybe some teachers like to stretch it to the 29th, but that's pretty much going to be the deadline for grades. It's going to be tomorrow night at midnight. Okay. So we just wanted to let y'all know about the grade deadline because that's super important. Uh, th- Now the kids who are passing this class, you'll be taking Part B in the spring, and Part B is going to be a SOL class. So at the end of next year, which would be sometime in May or June, you'll be taking the Algebra 2 SOL test. And typically we get pretty high pass rates for that because, if you can pass Algebra 1, it's almost a given that you're going to pass Algebra 2. Okay. So, whether you have me for Part B or whether you have another teacher for Part B, like Michael Wilkerson uh, or Lori, you're going to want to keep all your notes and assignments from this semester to help you out for next semester. Okay. And that's for my Part B students. So make sure you keep your work and make sure you turn in all your work tomorrow. Okay. And one more thing I did want to say before we do start this, um, if you turn in your last assignment today or tomorrow, I will give you an extra 100 on one of your assignments that you have a 0 on or that you have missing. So I will give you that extra 100 besides the 100 you'll be getting this week. And that's just a big thank you from me to you, getting your work done during this pandemic. I know it's been hard on a lot of folks, but you know, the show's got to go on, right? You got to keep on teaching, you got to keep on learning, you got to keep on turning in your work. So if you do turn in your work this week, like you should be doing, I will give you that extra 100 classwork grade. And if you're missing a test, you got all your classwork in, but you're missing a test grade, then that 100 is going to go to being a test grade. So whatever you're missing, whether it's a classwork or a test grade or a quiz grade, I will give you an extra 100 if you turn in your homework this week. Okay, so the homework this week is going to be on matrix multiplication. So what I'm going to do is I'm just going to go to the problem set and I'm going to work out problems from there because they are pretty much identical to what you'll see on your classwork today. Okay, let me grab it and we'll talk about it. Okay, so when we do matrices, you can add them, you can subtract them, you can multiply them by a number on the outside like we did last week. You could also multiply a matrix by a matrix. And that's what we're going to be talking about today, matrix multiplication. So the first thing we're going to do is we're going to talk about row by column. Row by column. And the first 3 questions on your homework this week, your last assignment, are going to be on row by column multiplication. Okay. So let's look at number 1 on the problem set. I've got a row, 3, 4, 5. And I've got times a column. The column is 2, 6, 1. Okay, so on the left side, you're going to see a row matrix. If a matrix has only one row, then we call it a row matrix. And on the right side, you'll see a column matrix. If a matrix only has one column, then we call it a column matrix, right? So we got the row matrix over here. We have the column matrix over here. So what we're going to be doing is we're going to be multiplying the numbers together. So the first two numbers, and I'll just circle them for you, are 3 and 2. So I'm going to circle those first. And I'm going to get 3 times 2. So what I'm doing is I'm taking the first component from each matrix, and I'm going to multiply them together to get 6. And then I'm going to put a plus sign, and then we're going to move on to the next two components, the 4 and the 6. See you, Coach? All right, 4 times 6 plus, and then I circle my last two components, 5 and 1. And I get 5 times 1. Okay, so let's simplify this a little bit because we can multiply the numbers together and then we can add all of them up at the very end. So I've still got my matrix brackets, so I'm going to write those first. And 3 times 2 is going to give me 6, plus 4 times 6 is 24, plus 5 times 1 is 5. So now when we add them all up, you should get 35. That's going to be your answer. So what we're doing is we're multiplying all the numbers together, first by first, second by second, third by third. And then we add up all the numbers that we get from that. Okay, and I'll leave that up there for a little bit, and then we'll try number 2 together. So this is called row by column multiplication. And it's the simplest type of multiplication you'll see this week. Okay, let's try number 2. We have 4, -2, 0 times the column -2, -5, 11. Okay, so our answer is going to be a matrix. So I'm getting the bracket started just in case. And we're going to multiply the first two numbers together. So 4 times -2. I just write 4 times -2. Plus, okay, now I'm going to circle the second two numbers, -2 and -5. -2 times -5 plus, and then I circle the third component, 0 and 11. So I'm going to have 0 times 11, and then I close up my brackets because we're done. Okay, so now we can multiply the numbers together. I'm going to get -8 plus +10 plus 0. So then when I add up all three numbers, I just get +2, and I'm done. Okay, so that's pretty much what the first 3 questions are going to be like. And I'll skip number 3 because you can do it on your own. Now, something interesting about this, since the first matrix is a row matrix, we know that it only has one row. But how many columns does it have? It has 1, 2, 3 columns. So this is actually a 1 by 3. 1 by 3. So I always put the number of rows first. That's how I got that 1 right there. And I always put the number of columns second. That's how I got that 3. So now look at the column matrix. What would the dimensions of the column matrix be? Column matrix. Well, how many rows does it have? It has 1, 2, 3 rows. So 3 times what? Okay. How many columns does it have now? It only has 1 column since it's a column matrix. So this is going to be a 3 by 1. So we have a 1 by 3 being multiplied by a 3 by 1. So now what I'm going to do is I'm going to switch my color to red, and I'm going to underline the middle 2 numbers. I'm going to underline the 3 and the 3 over here. These are called the inside numbers. The inside numbers. And the inside numbers have to match. The inside numbers have to match. If they don't, we can't multiply the 2 matrices together. And then I'm going to switch my color to blue, and I'm going to underline the outside numbers. The outside numbers are 1 and 1. And that is going to be the dimensions of the new matrix. So the new matrix that we got over here, this 2, this should be a 1 by 1 matrix. And all I'm doing is I'm taking the outside numbers that are underlined in blue, and I'm bringing them over here. So the new matrix that we get when we multiply, it should be a 1 by 1. And it is, right? Because it's got 1 row and it has 1 column. That's what a 1 by 1 is. So I'll leave that up there for a little bit, but you do need to know that the inside numbers need to match. And if they don't match, your product is undefined. But luckily they do match here, so you're actually going to get an answer out of all this. Okay? So that's going to bring me to number 4. So let's look at number 4. All right, so number 4 says, we'll look at part A first. A says 2, 1, negative 1, 0 times 6, negative 2, 5, 9. And I close it up. Okay? So 2 questions. 2 questions. The first question is, can these be multiplied? Can these be multiplied? That's my first question. Is there actually going to be a product? Or is the product going to be undefined and we actually don't get a product? My second question is, if they really can be multiplied, what are the dimensions of the result? What are the dimensions? What are the dimensions of the result? So those are the 2 questions that we want to ask ourselves. Can they be multiplied? And if so, what do we get when we multiply? Do we get a 3 by 2? Do we get a 1 by 1? Do we get a 2 by 2? What's the dimensions of the result going to be? So what we do is we look at the dimensions of what we have right here. Now, how many rows and columns do they have? Well, they have 2 rows, right? 2 rows. So I'm going to have 2 rows. But then how many columns do we have? We have 2 columns, right? For both of these. So this is going to be a 2 by 2, and this is also going to be a 2 by 2. Okay? So now we know that we're multiplying 2 by 2s. So can these be multiplied? Only if the inside numbers match up. The inside numbers must match. So I'm going to underline the inside numbers. I've got a 2 and I've got a 2. They do match up, which is great. So that means, yes, they can be multiplied because the inside numbers do match up. So we know that we can multiply these two matrices together and our product will be defined. But the second question is, what are the dimensions of the result? That's going to be the outside numbers. So let me change my color to something else. Let's say green. Let me underline the outside numbers. This 2 and this 2 on the outside. And that's going to make it a 2 by 2 when we get done with it. Because the outside numbers are going to be 2 by 2. So that's how I know what my result is going to be. That means when I multiply these two matrices, whatever I get, let's just use A, B, C, D, I'm going to get a 2 by 2 for my answer. And I'm taking that from the outside numbers, right? Let's try part B. Okay, so part B says 106. That's my first row. Negative 9, 1, 0. That'll be my second row. Okay, so what's the next matrix? 7, 8, 10. 7, 8, 10. That's my first row. And then 4, 2, 7. That'll be my bottom row. Okay, so with these matrices, can they be multiplied? Let's do the dimensions. Okay, so this has how many rows? It's got 2 rows, right? How many columns does it have? It has 3 columns. So this is a 2 by 3. Same thing with the next matrix. How many rows do we have in this matrix? We have 2. How many columns do we have? We also have 3 columns, right? So this is a 2 by 3 as well. Okay, I'm going to switch to red and I'm going to underline the inside numbers. This 3 and this 2. So do the inside numbers match up? No, they do not. So the answer to number 1 is no, they cannot be multiplied. And since they can't be multiplied, we're not going to have a defined product. Our product is going to be undefined. So there's no way we can tell the dimensions of the result because those inside numbers have to match up for us to actually take the outside numbers into consideration. Okay, so number 1 is no. Number 2 does not have to be answered because we are not going to get a product. Okay, I'll leave that up there for a little bit. So that's what number 4 is going to be like. It's just going to ask you, hey, can you find the dimensions of the 2 matrices that we give you? And if so, do the inside numbers match up? If they do, you're actually going to get a product. But if they don't, your product is going to be undefined. And that's the moral of the story. Okay, so number 4 should be easy for you. Now, the last 4, 5 through 8, we've definitely got to talk about. So let me get a new screen. Okay. Let me change my color back to white. Number 5. Okay. Number 5 says 1, 2, 3, 4. 1, 2, 3, 4. Close that up. And we're going to multiply it by 5, 6, 7, 8. 5, 6, 7, 8. Okay, so this one is actually asking, well, what do we get when we multiply these 2 matrices? And what we're going to do before we start multiplying is we're going to find the dimensions first. So we know that they're both 2 by 2s. We know that they're both going to be 2 by 2s. So I'm going to write 2 by 2 under them. Now, when you look at the inside numbers, they actually do match up. They do match up. So what that means is we can look at the outside numbers to figure out what the product is going to be. So the outside numbers, I'll circle those. They're both going to be 2's, right? So when we multiply these, we should get a 2 by 2 out of this. So we should get a 2 by 2. That's what the outside numbers tell me. All right. So what we're going to do is we're going to do row by column. We're going to do row by column. So the way this works is I'm going to circle the first row. I'm going to circle the first row and the first column. The first column. And I'm circling the first row because what we're going to be doing with that row is we're going to be multiplying this row by every single column until we run out of columns, right? Okay, so let's look at the first row and the first column. What if I multiply 1, 2 by 5, 7? Well, I'm going to have 1 times 5, 1 times 5, and all I'm doing is I'm multiplying the first two numbers together. And then I'm going to put a plus. I'm going to put a plus in the middle. And then we're going to multiply the next two numbers, the 2 and the 7. So I'm going to get 2 times 7. So now when I work it all out, I know that 1 times 5 is 5, and I know that 2 times 7 is 14, and then I can add up 5 and 14 to get 19. So my first number in my product matrix is going to be a 19. Okay. So now we're done with the first column. We're done with the first column, right? So what I'm going to do with the first column is I'm going to mark it out in red. I'm going to mark out the first column. And then what I'm going to do is I'm going to circle the next column and go from there. So let's circle the second column now. Okay. So now we're going to do the same exact thing that we did with the first column, but with the second column. So we've got 1 times 6, 1 times 6, I'll put it right here, 1 times 6, plus 2 times 8, 2 times 8. 1 times 6 is 6, 2 times 8 is 16, 6 plus 16 is 22. 6 plus 16 is 22. So that's going to be the next number in my matrix. I'm going to put it beside the 19. 22. All right. So what we just did was we multiplied the first column up here. I'm sorry, the first row up here. We're multiplying the first row by the second column. So now we're done with the second column, right? So I'm going to change my color to red, and I'm going to mark out the second column because we're done with it. So now we've exhausted all of the columns. We're done with all the columns, right? Now I'm going to mark out the first row, and I'm going to circle the second row. Circle the second row. And now the process is going to repeat all over again. Because what we're going to do with this bottom row is we're going to multiply by the first column, and then we're going to multiply by the second column. Okay? So let me erase this stuff over here, and we'll move on to the next thing. Okay. So let's multiply the second row by the first column. So I'm going to circle the 3 and the 5. And I get 3 times 5. Plus 4 times 7. 4 times 7. And that's going to give me 15 plus 28. 15 plus 28 is going to give me 43. So that's going to be my third number, 43. Okay. And now the last thing we need to do is we do the last row by the last column. Last row by last column. And I'm gonna erase this stuff over here, and I'm gonna put the new work in that spot. Okay. So I've got 3 times 6, 3 times 6, plus 4 times 8. 4 times 8. So 3 times 6 is 18. 4 plus 8, 32. 4 times 8, I mean. And then 18 plus 32 is 50. So 50 is going to be the last number, and we're done. So now that we're done with the bottom row, I'm going to change my color to red, and I'm going to mark it out. So we're done with all the rows. That means we're done with the problem. Okay. So what did I just do? I did row by column, but I did every single combination that I could. When I circled the first row, I circled the first column. And then when I'm done with the second column, I move on to the next column. Then I'm done with that row. I move on to the bottom row, and I do all the columns with that. And I just keep on going until I run out of rows and I run out of columns, and then I'll be done. Okay. We're going to do number 7 next. We're going to do number 7. And then I'll call it a day. Okay, number 7. I've got 5047, 5047 times 1001. And it's asking, what do we get when we multiply? Okay, so those are the two matrices that we're going to be working with. Now, the first one is a 2 by 2. The first one is a 2 by 2. I can tell because it has 2 rows and 2 columns. And the next one is just like that. It's also going to be a 2 by 2 because it has 2 rows and 2 columns. So I know I'm working with a 2 by 2 and a 2 by 2. So when I multiply those, I look at the inside numbers first. Since the inside numbers really do match up, then I'm actually going to get something over here. And then the outside numbers, I'm going to put a box around because that's going to be the dimensions of my new product. So this should be a 2 by 2 as well. Okay. So we know we're going to get a 2 by 2 in the very end, right? Okay. So now I'm going to change my color to white, and we're going to circle the first row and the first column. The first row and the first column. So when we multiply that row by that column, what do we get? Well, we get 5 times 1, 5 times 1, plus 0 times 0. And that's going to give me 5 plus 0, which is 5. So my first number is going to be 5. And again, all I'm doing is I'm multiplying the first row by the first column and seeing what I get. Okay. Now let's circle the second column, and we'll go from there. We're circling the next column. All right, so this one is going to give me 5 times 0 plus 0 times 1. 0 times 1. So that gives me 0 plus 0, which is 0. So the second number in the first row is going to be a 0. Okay. So now we're done with the first row. We can mark it out. Let's circle the second row now. Now we're only going to be working with the second row. And we'll do second row, first column. Okay. Now, if we multiply the second row by the first column, we're going to get 4 times 1 plus 7 times 0. And that's going to give us 4 plus 0, which is 4. So the third number is going to be 4. And then what's the last number going to be? Well, we need to multiply the bottom row by the second column, right? Last row by last column. That's what I'm going to be doing next. So let me cross this one out. Okay, so going down here, if I multiply the last row by the last column, I'm going to get 4 times 0 plus 7 times 1. 4 times 0 is 0. 7 times 1 is 7. 0 plus 7 is 7. So I get 7. Okay, and that's it. Check. All right. So, do you see anything weird about the product? Anything weird about this? Something that's not sitting right with you? What's so weird about this product? Well, it's the same exact matrix as we started off with, right? They match up, and there's a reason for that. 5047 over here, 5047 over here. So what gives? What's actually going on here? Well, it all has to do with this matrix. This matrix is called the identity matrix. It's called the identity matrix. And it's kind of like multiplying by 1, because when you multiply by 1, nothing changes, right? Same way with this. If you multiply any matrix by the identity matrix, you're going to get the original matrix back. So it's exactly like multiplying by 1 or adding 0 to something. You know you're not going to change anything by doing it. So if I multiply any matrix by the identity, the 1001 that you see right there, I'm going to get the exact same matrix back. So when you work on the classwork for number 7, I think, no, that's not the same. It's actually number 8 on the classwork, number 8. Number 8 on the classwork is exactly like this one. Because see, you're multiplying by the identity matrix. So whatever matrix you start off with, that's going to be your answer. So that's just a little tip on that. The identity matrix is always going to be 1, 0, 0, 1 if you're dealing with 2 by 2s. So number 8 is just like that. Okay? So that's the last problem I wanted to go over today. I see in the chat that somebody wants me to talk about number 7 on the classwork. I will do that on the next slide. So number 7 is a lot like number 8 on the problem set. So I'll probably do number 8, and from that you can figure out what number 7 is on the classwork. Okay. Number 8. 1, 3, 3, -1 times, this one is a 3 by 2, so it's going to be 4, 2, 3, -4, 0, 6. Okay, so the first thing I do before I multiply is I look at the dimensions. This one is a 2 by 2. I can tell because it has 2 rows and 2 columns. Over here, this is a 3 by 2, a 3 by 2. Notice how it has 3 rows actually, and only 2 columns. Okay, so now we know that the first matrix is a 2 by 2. We know that the second matrix is a 3 by 2. Now look at the inside numbers. The inside numbers that I'm about to underline. Do they match up? Do they match up? No, they do not. And since the inside numbers don't match up, we can't multiply these together. So this is undefined. This is undefined. And that's important because you got to look at the inside numbers before you multiply, so you know if you can actually do the problem or not. Because let me tell you, if you actually started doing this problem, if you actually circled the first row and the first column and you just went on your merry way, what would happen is you would multiply the 1 by the 4, and you would multiply this 3 by this 3. But then what about the 0 at the end? It doesn't have a number to match up with. And that's the problem. That's why you can't multiply these two. It just doesn't work.